my dear students. We have a topic now. We have to talk about it, and it's called the annuities. Annuity is usually we have two types of annuity. We have, like I'll show you right now. Here we go. The annuity is a sum of amount of money which is similar and it's paid on regular basis. Like as example, if we say steady basis, like as example, every 2 months, every 3 months, and so on. And the amount itself is similar, means it's not increasing, it's very similar to each other. As example, if I say like this, pay $200 every 3 months. So here, this is $200 and it's paid every 3 months. That's why we call it annuity or annuity. So annuity is, we have two types of different annuity, like what you will see here. The payment interval, of course, length of time between it's called interval. So the length of time between each annuity and the other. Terms of annuity, length of time from the beginning of the first payment until the end payment is done. Periodic rent and annual rent, those are also things to know about the annuity. What we care about, types of annuities, certain for fixed term, contingent for indefinite or uncertain, and perpetuity for infinite numbers of payments. We have examples, and we will see it now. It will come clear when we talk about it. The most important part is here, is this part. About the annuities, the most important part is these parts or these words. So what are the types of annuities we have? And that is the most important part. Actually, we have two types of annuities, the main types, or the major. Ordinary one, payment are made at the end of each payment period. So the ordinary is made at the end of each payment period. But annuity due, payments are made at the beginning of each payment. So what's the meaning of this? Ordinary means if I tell you a guy deposited $200 in a bank at the end of every 2 months. So when I say at the end of every 2 months, that means when I say at the end of 2 months, that means this is ordinary because it's at the end of 2 months. But when I say annuity due, means payments are made at the beginning of each payment period. So if I say a guy deposited $200 in the beginning of each 2 months, here we are in an annuity due. Deferred, which first payment is delayed for a specific time period, for a time period that may have to be calculated. But mostly we are working here on the ordinary and annuity due. Ordinary and the due ones. So the ordinary at the end of and due at the beginning of the period. So one of them at the end of a period and the second one is at the beginning of the period. We have simple annuity and we have general annuity as well. If you can say here like this one, simple ordinary annuity, the interest rate is 6%, but we will depend on our working first because we're still in the simple interest. We'll do it as a simple interest first, then after that we'll go to the compound interest. So we'll do it firstly on the simple interest. Once we're done, we'll go for our own compound interest. So here, if I wanted to tell you about the annuities, and we will take an example. We will go to an example right now. Here we go, and we will use slide A-N-N-U-I-T-I-E-S, annuities. Let's say like this, an example like this. Sam use to deposit $200 monthly for 1 year long with simple interest of 5, or let's make it 6% annually. Required calculate the sum of annuities in the following cases. 1, if he deposited the annuity at the end of every month. Second, if he deposited the annuities at the beginning of each month. Here we have 2 cases. The first case, if he deposited the annuity at the end. We said the end one is the ordinary. So this will be ordinary, O-R-D-I-N-A-R-Y, ordinary. So this, sorry, I'm not replacing anything. Ordinary, O-R-D-I-N-A-R-Y, ordinary annuities. And the second one will be due, which in the beginning. So the one in the beginning will be due, and the one of the end will be ordinary. Like I told you before, payments are made at the end of each payment period. So let's go first. Basically, we will work on the one by one and see what we will do here. We can extract now the data. So let's say the 200s, or we call it D. Control and C will give them D will equal 200. So D is the amount. D denote, or the amount of payment. The amount of payment, or the regular amount. Let us say regular, so the students will know that this is always there. So the regular amount of payment here is D, and D will equals $200. Okay. We have the period, the whole period, SH, is the whole time equal here 12 months. We have also SH1, which is the time between duration. This is the whole period, which in the example was 1 year. Like if you come here, monthly for 1 year. So we'll say now that SH is the whole year. SH1 is the duration between each annuity and the other. Okay. Now we want to calculate. We have our own. The sum of annuities, sum will equal. We have first also to calculate the number of annuities. We call it M will equal the number of annuities, which here will equal all the period she SH will equal SH divided backslash by SH1. So it will equal, then it will equal SH is 12 months, and the guy used to go SH1 is 1. Here the SH equal 1 month. So here that will have M will equal 12 sums. So you went to the bank 12 times. By other meaning, the whole period was 1 year, which is 12 months. Between each annuity and the other, 1 month. M is the number of times he went to the bank to deposit. So it will equal SH divided by SH1. So it will equal SH12 divided by SH1, 1. So he went 12 times or 12 deposits. We have a rule now. I will just explain it. The sum of annuities will equal sum of annuities will equal the regular payment is the time M or the number of annuities. So this is the first thing. How many times he went to the bank and each time he put how much. So this will be the principal plus the amount again, D, multiplied by the interest rate. So the interest rate was, let's see, 6% annually. It was 6%. So here the rate times multiplied by M divided by 2. M backslash 2. What is the meaning of this? This is the average of the M. This is the average of the number. He went to the bank. Then multiply by the first deposit. How long it takes the first deposit? If we say that he goes to the bank every month, and we are doing now the ordinary. So the first deposit, if they are 12 deposits, the first deposit was after 1 month. Because now he stayed 1 month he didn't go to the bank, then he went at the beginning of the second month or the end of the first month. So the period of time till the end of the whole time, it's 11 months, plus the period of the last sum, the last sum, 200, the last 200, if we say the first 200, he deposited in the bank after 1 month. The second one, and the third, and the fourth, and the fifth, and the sixth. Number 12 will spend 0 time in the bank because it will be at month 12 at the end of month 12. Okay? That is this area divided by 12, backslash 12. Because we are here calculating in months. We are here calculating in months. So basically, that's what we will do right now. Here, D, or the deposit, is 200. Let us substitute now 200. Then times, how many times he went to the bank? 12 times. That is in brackets, D times M. Then plus D again, which is $200, multiply by R, the interest rate, 0.06. So it's here 0.06. Multiply by number of deposits is 12 divided by 2. That will give me 6. 6. Multiply by 11 divided by 12. 11 divided by 12. Multiply by 11, because 11 here is 11 months, and 0, that will be 11 divided by 12. 11 by 12. And we'll see this, how much it comes. So here, it will be, like if we calculate it, we can go to the calculator here right now. Let's go to our calculator and go to the calculator here. Okay. So 200, let's go like this. 200 times 0.006 times 6 times 11 divided backslash or divided by 12. That will give me $66. So that will give me $66. Now I will go here and put 2,400 plus $66. So it will equals $2,466. So this amount, if you stay regularly paying like this to the bank, $200 every month for 12 months, at the end of each month, which is ordinary, at the end of this period of time, all he will get is $2,466. How about if it was this now, we had the regular. We have the regular ordinary now. So this solution is for ordinary annuities. How about if I want to make it, if I want to go now into due, the due ones or annuity due, which is in the beginning. This is at the end of each period. The other one will be in the beginning of each period. Let's go now and see what we will do. Now, let me take this out and just work here, increase the area by which I will work. And I will say here solution is based on the annuity due. For the annuity due, like we see here right now, that will be means in the beginning, deposit in the beginning. But one thing I just want to tell you, nothing is changed from the basics. Like as example here, all the basics are the same. So the D is the D, the SH is the SH, the duration between each one and the other is the same. The M is the number of annuities. Nothing will change. Control and C. For that reason, I will do it here again. Here it is. But what will change? The length of the first deposit and the length of the last deposit. So it's the length of the first deposit and the length of the last deposit. I don't want to put more symbols. Just I will say it here. I will show you how to calculate it and do it. So here we will go again and say the sum again, but the only different will be in this part. This part, no difference. Everything is the same. Control and C, and we'll go here and put it back, Control and V. But the last thing is, because the last thing in this equation is the time of the first annuity, how long it took in the bank, and the time of the last annuity. Here we will find that in the beginning means that he's spending, he's going to the bank to deposit every month. That's fine. But in the beginning of month one, that means that the first sum, the first $200 stayed in the bank for the whole period, which is 12 months. And the last annuity, number 12 annuity, stayed in the bank for 1 month because he started from the beginning, so it stayed in the bank for 1 month. And this is also will be divided by 12 because our calculations all on the 12. Consequently, same things here are the same. So the M, these numbers are the same. I will take it back, same as exactly there. But only the difference here will be on the calculation of these. It will be times 13 backslash 12. Why? Because now the first sum at the beginning of the first month in the 12 months, so it stayed for 12 months. The last sum before the end of the 1 year was 1 month. So that's why it's multiplying by 13 divided by 12. Same thing here. So the first amount, which is this amount, which I'm talking about, is, let me enlarge it just a little bit so that it will be clear for everyone. Now, the first amount is 200 times 12. That will give me 2,400 if I use my calculator, plus the second part, 200 times 0.06. Let us do it like this. 200 multiplied by 0.06 multiplied by 6 annuities, because you do it 12 divided by 2, which means 6 multiplied by 13 divided by 12. That will give me $78. $78. So that will equal $2,478. $2,478. If I see here now, if I just want to see, I will know now that always the due annuities, the annuities due are always greater than, we can say like this, annuities due are greater than, always greater than ordinary dues or ordinary annuities. Here it is. Why this? Because it stayed in the bank longer. Here it stayed in the bank for 13 months, while here it stayed only in the bank for 11 months. That is about the annuities. I hope you guys understand it, and I will work on it on the board also for more clarifying for the to be shown up for the how we calculate the months and how we put concern into the months, how we calculate the number of months, and so on. So I will do it again on the board in front of you, and it will be shown up. It will be a bit clear than here now. Hopefully for everyone that he understands. Thank you. Remember always one thing. Always remember that the annuity due are greater always than ordinary annuities. Thank you. Thanks so much.